This is another example of a calculation involving a weak base. And much like the weak acids, we almost always need to make an ice table for these problems. So in this problem, we're told that morphine is a weak base. We're given the concentration of the morphine, and we're told that when it has this concentration, it has a pH of 10.5. And we want to use this information to find the Kb for morphine. So they've given us the initial concentrations, and they've given us one of the final concentrations by giving us the pH, because by giving us the pH, we can find the hydroxide ion concentration. So I can use that information to find all the equilibrium concentrations. I can plug those into the expression for Kb, and I've got my answer. So the first thing I need to do is write down the equation. So they didn't give us the formula for morphine. So oftentimes what we do for generic bases is just use B to represent that base. So B will be my morphine. And we're going to react that with water. If this is a base, then it's a proton acceptor. So it's going to steal one of the protons from the water, leaving us with a hydroxide ion. And if it stole that hydrogen ion, it's going to become BH+. Alright, so when I build my ice table, they gave me the initial concentration of the base. We don't worry about the liquid water. The hydroxide and the conjugate acid will both start at 0. So the change will be minus X, plus X, and plus X. So at equilibrium, I'll have X, X, and 0.15 minus X. So if I had some way to find X, I would know all of my equilibrium concentrations, and I'd be able to plug it into the Kb expression, and I'd be done. And fortunately, we do have a way to find X, right? If I know the pH, I can find the hydroxide ion concentration, right? And that hydroxide ion concentration will be X. So once I find the hydroxide, I'll be able to find the other two. So they're giving me the pH. So I think the easiest way is to first find the pOH, and then from that I can find the hydroxide ion concentration. So I know pH plus pOH is equal to 14. So that means the pOH is going to be 14 minus the pH, or 3.5. And let me move this guy up, give us a little bit more room. I know that the hydroxide ion concentration is 10 to the minus pOH. So my hydroxide is going to be 10 to the minus 3.5. Or that's going to be 3.16 times 10 to the minus 4 molar. And we'll finish this off on the next slide. All right, so here's our ice table again, just written a little bit neater. We've got the hydroxide ion concentration that we found last time, right? And the hydroxide ion concentration is going to be X in this case. So I know that this is 3.16 times 10 to the minus 4. The BH plus is also X, so that's going to be 3.16 times 10 to the minus 4. The equilibrium concentration of the morphine is going to be 0.150 minus X. And to those three significant figures, it's actually not going to change. So I get 0.150 again. So now that I have all the equilibrium concentrations, I can plug that into the Kb expression. So I know Kb and I can plug in my values. And when I plug those in my calculator, I get a value of Kb